So far we have talked about representing one quantitative and one categorical variable. We've looked at tables that showed relationships between two categorical variables, and now we're going to start talking about how we can display relationships and discuss relationships between two quantitative variables using scatter plots. So let's talk first about the characteristics of a scatter plot. Scatter plots have two axes. We have this horizontal axis that we will call this variable the explanatory variable. I like to remember that because it's got the x in there, and this is typically in the past math classes the x-axis, and so our old y-axis, this is going to be our response. So here we're comparing two things: the percentage of a region that is considered woodland compared to the grouping behavior of deer. And so each of these dots represents a data point. Don't ever want to insult anybody's intelligence, but I want to just make sure that we talk about all the things. So each data point is going to represent, we have a percent woodland, and then we have a group size. It's going to have an X and a Y, and they are going to be intentionally grouped together based on the region. So each one of those data points represents a region. It's going to have its percent woodland area and then its group of deer size. And so we're going to examine some things about these scatter plots. We're going to talk about their shapes, much like we talked about one quantitative data when we talked about histograms and box and whisker plots. And so let's talk about the ways that we will discuss what a scatter plot looks like. We want to hit three different things. I don't have a fun mnemonic like we do for one quantitative variable. But we want to talk about the shape of the scatter plot. We want to talk about the form, and we want to talk about the direction. So the shape that we're probably going to see the most is linear. But we might also see some curved. And if you move on and you take other stat classes, you might talk about specific different types of curved scatter plots. When we talk about the form, we want to know, are the data points tightly packed together? Are they spread out a lot? And so we would talk about them having we are going to talk about the strength. So if they're tightly packed together, they would have a strong form. We would, if they're spread out a lot, they would be weak. And somewhere in the middle, we would call moderate. And then direction is, are they going up to the right, down to the right? That's positive or negative. Positive is up to the right, negative is down to the right. So if I look at this first one, and much like I do with a histogram or a stem and leaf plot or a dot plot, I like to just draw what it looks like it's doing. This is probably not exact, but this is what it looks like it's doing. So it looks like we have a curved relationship. It looks like those data points are pretty close together in the pattern, and so we'll say it's strong. And then it goes down to the right, so it's negative. And of course, if we were to write this up, much like we did when we described a histogram or a quantitative data distribution in the past, we want to make sure that we use complete sentences. We want to use context and all that stuff We don't have a lot of context for these. We're just sort of giving examples right now of what these might look like. This one over here looks like it goes this way. I would say this is linear. It's in a straight pattern. I would call this about moderate, somewhere between moderate to strong, since all of these data points pretty much follow the same pattern. And then it is positive. It goes up to the right. And then this last one, again, these lines I'm drawing, I'm just giving a rough idea of what the pattern is. So here we have another linear pattern. I might call this strong. And then it is negative. And there's actually a value that's going to give us an idea of how strong a relationship is. And that value is called the correlation. So when we're talking about these two things, we want to know, is there some sort of relationship? And if we put a number on it, which we can calculate using our calculators, then we can start talking about whether or not two things have a correlation. And so what I'd like you to do right now is in list 1, I want you to put this data. Yes, we're talking about drug use. And in list 2, put this data. We are trying to see, is there a relationship between marijuana use in these different countries and the use of other drugs? So go ahead and put that in your calculator, and then we'll talk about creating or calculating a correlation coefficient. So as you can see, I got a fancy new calculator to use. So hopefully this is easier for you to see when I'm trying to demonstrate what to do. It's really important that you put your list in the proper order, because the value in list 1 on the left, 17 here for my first data point, represents the percent of teenagers in the Czech group. Well, in this case, it's Denmark, that have used marijuana, and the second list 2 right next to it, the percent of teenagers who have used other drugs in the Czech Republic. We want to make sure that the values from the same country go together. This way, when we create a scatter plot, we're going to get data points that represent the countries. So if we want to calculate a correlation coefficient, we are going to go to stat, calc. We're going to choose option 8, this lin reg a plus bx. We're going to tell it what our x and y lists are. We're going to use that first list as x and the second list as y. And so we can just go down and calculate. And so I see a value for a and b, but I don't see a value for r. R is what we call the correlation coefficient. And r is always going to be between -1 and 1. So 1 is a perfect straight line that's positive. -1 is a perfect straight line that's negative. Any correlation coefficient close to 0 is going to represent a weak relationship. Anything close to 1 or -1 is going to represent a strong relationship. And so if r is not showing up, I'm going to hit mode. I'm going to go down to where it says stat diagnostics, and I'm going to arrow over and hit enter to turn them on. And so now I can make that calculation again, and I'm going to get a couple more values. Right now we're going to worry about what r squared is. And so I'm going to I'll take the first 4 numbers, or not r squared, I'm sorry, I misspoke. R. I just want to know what r is. So I'll take the first 4 numbers, 0.9341. So it looks like we have a value that's close to 1. Remember that correlation coefficient is always somewhere between -1 and 1. Closer it is to positive or -1, the stronger it is. So this looks like a strong correlation between marijuana use and other drug use. But before we say anything about that, we want to look at this scatter plot because we need it to meet some conditions. So if I hit second y equals, and I turn my first plot on, and I choose this first option, the dots, and I keep my L1 and L2, and then of course I always zoom 9, I can look at the scatter plot of my data. And what I want to do is try and describe this data. It looks like it's linear. It looks like it's going in the straight line. It looks like it's pretty tightly packed together, these data points, and it's going up to the right. It's positive, and that's represented in our R value being positive 0.9. That it's a strong relationship. It's a positive relationship. And what's important, the conditions we need to make is that we need our data to be linear. In order to use correlation coefficient, our data needs to be linear. It is, and it needs to not have any outliers. So an outlier would be a point that is off the path, something like this, much like we talked about when we looked at histograms. That would kind of mess with the rest of the data points. And so we don't have any outliers. It looks like our data is linear. And so we can say that we have a strong, positive, linear relationship between marijuana use and other drug use. And so it would be appropriate to talk about the correlation between those two things. And so there is some relationship here that exists based on our data set that exists between marijuana use and other drug use. So the really, really important thing that we would never want to say just by looking at a set of data like this is that marijuana use causes other drug use. We can see that there is a relationship that exists based on our data. There's a relationship that exists between the use of marijuana and other drugs. The correlation is pretty high. The larger percentage of teenagers who used marijuana, the larger the percentage of teenagers who used other drugs. But what we cannot say just simply based off this data is that one causes the other. The only way to do that is through experimentation, and that's not where this data came from. So be very, very careful. Correlation, and you may have heard this before, does not equal causation. No matter how much you want it to, just because we have a relationship that we can see based on a data set, that doesn't mean one thing causes the other. So let's just make sure to say that there's a relationship, there's a correlation, but we should never say one causes the other unless we have an experiment that's been done. And we'll talk together about what a lurking variable is. This is something that's connected to both of the variables we're comparing that might be causing them to have the relationship we see, even though they're not related. So if you remind me in class, we will talk and I'll give you an example of when that happens. As always, make sure you wait to the end, you answer the questions. If you need my help, please, please, please ask. I'm more than willing to help. Take your time and good luck.